Okay, so 7-3. So on Wednesday, we just briefly started this, so you should have this first part written down. We talked about how we get a hyperbola here. It's from the two cones and then a plane intersecting both. It looks like a double parabola. And we also talked about how we could tell the difference now when it's in this expanded form between a circle, ellipse, and a hyperbola. And then we looked at the sketches of the two types of hyperbolas. You have a horizontal and a vertical. And so what we're going to get into now is the equations and then all of the parts. And then we'll actually graph a few today.
Will one of the axes always go through the person of the hyperbolas?
Yes. So, and that will always be the transverse. So the transverse could be horizontal or vertical, just depending on the type of hyperbola you have. Okay. So here are the two equations, and you have two different ones because it matters on which term is positive. That will tell you the direction of your hyperbola. I am going to give you all graph paper because it will make this easier to have it on a graph. Okay, so it's a horizontal hyperbola, so opens left and right, if the x is positive. It's a vertical hyperbola, so opens up and down, if the y is positive. Otherwise, that looks just like the equation of an ellipse. A will be your horizontal distance, B will be your vertical distance still. Okay, H and K is still your center. So we're going to have this graph, and I will talk you through all of the parts. So there are quite a few parts with a hyperbola, but once we start graphing it, then it becomes a little bit easier. Okay, so first of all, this is if it goes through 0, 0, the center. So start with your center, and then you will graph this rectangle, depending on what A and B are. So you would go from your center, you're out right and left A units, just like we did with an ellipse, and up and down B units, just like we did with an ellipse. Okay? And then that gives us this rectangle. So we sketch in the rectangle. So in this case, this is a horizontal hyperbola. So my vertices are on the horizontal axis. Okay, the edges of the left and right edges of that rectangle. asymptotes. So the asymptotes are what's in blue, and those go through the diagonals of that rectangle. So I would draw my rectangle, draw the vertices, and then draw the asymptotes. So what's in blue? So the purpose of the rectangle is so I can find my vertices and my asymptotes, because I need those two things to draw the hyperbola. So I do the rectangle first, okay, and then I do the asymptotes, and then I can draw the hyperbola. So the hyperbola, the actual graph of the hyperbola is what's in green, okay? And then you see the foci there, but those are part of the graph of the hyperbola as well. Okay. So we need to talk about a few of these things because you have to be able to label these parts. So you have basically 4 lines. You have your transverse and conjugate axes. So those always go through the center. So you could place your center and then go ahead and do your transverse and conjugate axes. So if the transverse always goes through the hyperbola. So in this case, it's a horizontal line, okay, because my hyperbola is horizontal, the transverse. And the equation is y equals k, so that y coordinate of the center. The conjugate is x equals h, the x coordinate of the center. And in this case, they would just be y equals 0, x equals 0. The asymptotes are lines, okay? So we put those in slope-intercept form. Okay, so the equation of the asymptotes, so if I look at this one here, the slope from the center to the corner, I'm going up b units, right a units. So b over a, x. And then this just goes through the y-intercept. It just goes through at 0. So technically, this is a plus 0. And then my other asymptote, I would go down b units and right a. So negative b over x. And again, that goes through 0, 0, so plus 0. Okay, vertices are points. So you label those as ordered pairs. Foci are points. So you label those as ordered pairs. The foci equation for a hyperbola is a squared plus b squared equals c squared. So this is just the Pythagorean theorem for a hyperbola. Ellipse, remember, is a squared minus b squared. So we'll practice just graphing a few central hyperbolas where our center is just 0, 0 first before we do ones that have a different center. All right, well, the first thing I want to do is identify if I'm looking at a horizontal or a vertical hyperbola. So it's whatever term is positive. So in this case, which one's positive, the x or the y? The x. So this is a horizontal hyperbola. with a center at 0, 0. Because I don't have an H or a K, so I don't have parentheses with the X and the Y, so I know my center is just 0, 0. So it's over A squared, so A would be 4, and B would be 3. So that's going to give me the dimensions of my rectangle. So from my center, I still go out left and right 4 units. So I'm going to mark those, and then up and down 3. And that is what I will use to draw my rectangle. So I need the rectangle so I can find the asymptotes. Since it's a horizontal hyperbola, I know that my vertices then are on the horizontal axis. So this time it doesn't matter which one's bigger, like if A or B is bigger. It just matters which one's positive. Okay, so those are my vertices. So I label those as ordered pairs because they're points. So that's negative 4, 0, and 4, 0. Okay, my transverse and conjugate axes go through the center. So I have, and the transverse is the one that goes through the hyperbola. So if it's horizontal hyperbola, then your transverse is the horizontal axis.
On that place, if you want us to draw any axes, or can you just label the X and Y axes?
You can just label the X and Y axis, but if your center has moved, then you'll need to draw them in. Okay, so this means this is the conjugate, because that one does not go through. These are lines, so they're equations. If it's a horizontal line, it's y equals. Vertical lines are x equals. And then you're doing the x and y coordinates of the center. So y equals 0, because the center is 0, 0. X equals 0. So you can either label them on the graph or to the side. Sometimes things get really crowded, so I usually will do like the axes and the asymptotes just right there on the graph, but the points I'll put on the side just so it's easier. But they need to be labeled. Okay, drawing your asymptotes so then we can draw the hyperbola. So they go through the diagonals. We will talk about their equations, but let's go ahead and sketch in the hyperbola. So they go through your vertices, and these are asymptotes. They don't touch or cross, but they approach. So should draw them to be getting close, but not touching or crossing. Okay, now the asymptotes are lines, and they're not horizontal or vertical, so we should put them in slope-intercept form. So y equals mx plus b. So for this top one up here, so I'm starting at 0, 0, my center. And for the slope, I had to go up 3 and right 4. So 3 over 4x, that's my slope. And then my y-intercept is where it goes through the y-axis, which is just 0. So plus 0. The plus 0 isn't necessary since it's just 0, but I like to go ahead and put it in case it's not sometimes. Okay, now let's look at the second asymptote. So what's the slope of the second asymptote going to be? Good. So you went down 3 and right 4, so negative 3 over 4x, and again plus 0. Okay? The last thing, yes?
Wait, what was the change of 0 to?
Well, the center, if the center is in a different place, then your asymptotes will be in a different place, so they will cross the y-axis differently. So we will see an example when our center is not 0, 0. Okay. The last thing is the foci. So a squared plus b squared equals c squared. So 16 plus 9 equals c squared. That's 25. So 5 plus or minus 5 is c. You can just write positive 5 since c represents a distance, but you are going left and right. And the reason why I'm going horizontal is because this is a horizontal hyperbola. So your foci will be inside the hyperbola. It's just kind of like they were the inside the ellipse. To make them inside the hyperbolas, that's why it had to be a squared plus b squared. So I go 5 units left and right from my center. So putting the little asterisk is what will represent that that's where your foci are. And then you need to write their location, so write their ordered pairs. So that is negative 5, 0, and 5, 0. Okay, so those are the parts. So you needed all of these listed and graphed, and then you needed these listed and graphed, and our hyperbola obviously graphed as well. So on your quiz, you'll be given 3 graphs, and you'll have to determine whether they're a circle, ellipse, or hyperbola. And then you have to make sure that if it is a hyperbola, that you have all of the parts written out. If it's an ellipse, you'll need all the parts written out for an ellipse. And we'll talk about this more on Tuesday when we prepare for your quiz Wednesday. Okay, so we're going to do another one, this basic one where the center is 0, 0. So give us a little bit more practice before we change it up and do one that's not at 0, 0. So first I want to notice that the order is different. So I'm going to go ahead and rewrite it. So I put the x first. So x squared over 4, I'm sorry, that's a negative x squared over 4 plus y squared over 4 equals 1. Okay. So I see that A and B are the same, but that still doesn't mean it's a circle. It would only be a circle if they're both positive or both negative. They have to have the same sign and be the same number. Okay, so which one is positive, x or y? So that means it's a vertical hyperbola. I don't have an h and k, so my center is 0, 0. A is 2, and B is 2. Okay, so draw the center, draw your rectangle, which in this case is a square. But you're going left and right 2 units and up and down 2 units. Okay. So then my axes go through the center. So I have since it's a vertical hyperbola, which one is the transverse axis? The horizontal or the vertical? The vertical. Okay. So horizontal lines are y equals, vertical lines are x equals, and it's the x and y coordinates of your vertex, or I'm sorry, of your center. So x equals, the x coordinate is 0, y equals, the y coordinate is also 0. Okay, my vertices will be on the transverse axes. So they are here and here. This is a vertical hyperbola. So that is 2, 0. I'm sorry, 0, 2, 0, 2. 0, 2, and 0, negative 2. Okay, before I can draw in the hyperbola, I need the asymptotes. So we can sketch those. We can go ahead and talk about their equation too. So you have 2 asymptotes. So if I want this equation, if I go up 2 and right 2, what's the slope? 1. So 1x. And then what's my y-intercept? 0. So plus 0, which just means y equals x. And then for my second asymptote, y equals negative x. So down 2 and right 2 is negative 1. So negative 1x plus 0. Okay. Let's draw in our hyperbolas now. So here and here. The last thing is the foci. So a squared plus b squared equals c squared. So 4 plus 4 squared, that's 8. So c is the square root of 8. So you have to know what that is approximately so you can graph it. So it's close to 3. Should be close to 3. So again, the foci will be on the transverse axes as well. So here and here. Okay, when I write that as an ordered pair, though, I need it to be exact. You could simplify square root of 8 to 2 square root of 2, but you don't have to simplify your radicals. So remember, C is the distance from the center. So I did not move left or right, so I'm still at 0 for my x coordinate. Okay. Then I went up square root of 8. So from 0 for the y coordinate, I went up square root of 8. And then I also went down square root of 8. Technically, since that's just a 0, you don't need it there. But, you know, when it's not, you have to have that y coordinate of your center. So I'll go ahead and write it there. So here's my parts. So I have to make sure that I have. Now all the other work that I'm showing, you're going to need so you can help find these parts. But you want to make sure that you circle or have things organized so I can see where they are. So all the parts need to be labeled and graphed, and then draw in the hyperbola. So I have sometimes students will have all of the parts graphed, but then they forget to just draw in the actual hyperbola. So what I have in green. So that's part of it. That's the main idea here. So don't forget that. Questions about this? Okay, we're going to look at an example before we do a graph where the center moves. We're going to look at an example where we're given the graph and then we have to write the equation, because I think that will kind of help us then. Okay. All right. All right. So first of all, we want to make sure we have the right equation. So since this hyperbola is horizontal or vertical, so which term should be positive? The y. So I know that I want this equation. Alright, I'm going to follow the steps here that it says then. State the location of the vertices. Okay, so here's my vertices. Each grid line counts by 2, because that's why they have 10 labeled here. So okay, so then my vertices would be 3 or -3, -1, and -3, +3. Okay, the equation of the transverse axis. Okay, so that's the one that goes through. So a vertical line, meaning it's x equals, where does it go through x? -3. So -3. Okay, so my center, well, the x coordinate is -3. And then to find the y coordinate, okay, so I need to be going the same distance in both directions to get there. So between vertices, I want to count how many units away I am. So there's 1, 3, 4. So those are 4 units apart. The center needs to be halfway between. Okay, so that would be 2 units, which would put me where? 1. Good. So -3, 1. So then my conjugate axes is y equals 1. Okay, so remember, they're the x and y coordinates of your center is how you can find your transverse and conjugate axes. Okay, so it would have to, we're going to go ahead and write the equation. It would need to give you a little bit more information. Just based on the way that this looks, I can tell that my rectangle is going to be here. And for you to do this on your own, you would have to have a little bit more information to know exactly where your rectangle is. So I can tell that my A is 1. And that's just based on what the graph looks like. Again, you would have to know a little bit more information to know that. But you can determine B because you have your vertices. So what would be, what's B? 2, right? So the distance from the center to each vertex, your vertical distance. So B is 2. So if I have the center in A and B, then I can write the equation. So remember, it's minus h and minus k, so you want to do the opposite. So this will be x plus 3 squared over a squared, which is 1. 1 squared is 1. Plus, what would I write with y? Minus 1 squared over 2 squared, which is 4, and then equals 1. So don't forget the equals 1. This is an equation. Okay? Okay, the next problem we're going to do would be a graph where the hyperbola is not at 0, 0. The center is not at 0, 0. It'll take us quite a bit of time to get through that, so we'll just wait and start that on Monday.